Hello everyone, this is a follow-up session on the workshop what we had at IoT conference on the topic Sensor to App. A complete hands-on workshop to build your IoT solutions from one end to the other. Unfortunately, we were not able to complete this workshop due to some internet issues we had there. So as promised, we are capturing this video session so that you can follow from this. So without further delay, let's proceed to the slides. Well, in the workshop, we had a brief discussion on introduction to IoT, and even we had an overview of IoT architecture. I would not like to go on these discussions again, but before we proceed to this session, I would like to have a quick review on the use case what we had. That's the smart street light. So now, what is this use case all about? Well, the plan is to send somehow the street light information, like whether the light is on or off, if it is on, at what brightness percentage it's on at, and some critical informations of this kind sent to the cloud. Now after sending this to the cloud, okay, we may do some data analytic as required. Now to achieve this, the plan is to have every pole with a device which can send the data wirelessly. Now what do I achieve by doing all these things? Well, the problem is, as we all know, as the time passes, there's an increase in demand of electricity, leading to many environmental issues like increase in carbon footprint, climate change, light pollution, and many other. So what is the solution for this problem now? Well, we need to identify some sources of wastage of electricity. So one possible solution is to reduce the power usage in all sectors like housing, industrial and corporate, which seems to be a bit difficult because of our lifestyle. And yes, for sure, we need some awareness program within us so that we can achieve it. And the other one is to identify various areas in public sectors where we can conserve energy to solve the above concerns. One such thing is to avoid the wastage of power in street lights. Well, this could be done manually too, but the efficiency matters. Moving forward, how do we achieve this? Well, the plan is to make sure that every pole acts as a node, and these nodes communicate with a central access point, and this access point is going to send the data to the cloud. In our case, every node is going to be based on node MCU based on ESP32 by expressive, and this node MCU will be connected with the light sensor. That's a simple LDR. And the access point, and we may see this access point as a gateway, is going to be based on a Raspberry Pi. In our case, every node is going to be based on node MCU based on ESP32 by expressive, and this node MCU will be connected with the light sensor. That's a simple LDR. And the access point, and we may see this access point as a gateway, is going to be based on a Raspberry Pi. Well, the plan is the node sends the data to the access point, and the access point sends the data to the cloud, and from there we may pull the data to the app as required. By doing all this, we may see the beneficiaries in form of general public, the control room, and the component vendors. Now without wasting more time, let's go to the implementation and let's see what we have there. Now, when we talk about IoT implementations, we all know that every IoT project starts with an end called as thing. So let's start with our thing. As mentioned in previous slides, our thing is called as Node MCU, which is based on ESP32. And this is a device which has a built-in Bluetooth and Wi-Fi. And the board is a very simple board with one single LED and a simple tactile switch, and it has some good amount of GPIOs, and it has an USB interface using which you can do debugging. So let's proceed further to program our device. The platform what you're going to use to program this device is Arduino. So the first sketch what we would like to try is to just toggle an LED. As mentioned, the board contains a single user LED connected at GPIO2. So you may observe it here, and the interface is a simple current syncing circuit. So the LED is connected to the pin GPIO2 here, and it is sourced via 3.3 volt. In order to glow this LED, we need to make sure we add our board to the Arduino IDE. So let's follow the simple steps. Let me change this desktop here. I have made sure that I have kept the Arduino IDE open here. Let's go to File, and in File we have Preferences. So make sure you add additional board manager URL here. You have to add this path. So it's a JSON package, and once you add this path, go to Tools, go to the board manager, which is under board tab here. So it may take some time based on your internet connection. It will try to download all the possible boards what it has, and in the search bar you may type ESP32. Now it's going to show you ESP32 by Expressive System. Make sure this is installed. I have already installed this, so that's why you can see it here. So make sure you have to install this. Once this is installed, the other thing you have to do is go to Tools and select your board. So the board I have already selected is DoIt ESP32 Dev Kit version 1. So you may find it here somewhere below in ESP32 boards. So it's here. So make sure you select that. And once it's selected, please go to File, Examples, First Basics, and Blinky, or it's called as Blink. So click on that. So a new tab is open. So let me expand this. So it's just a simple code. And if you are aware of Arduino programming, you will see these two major functions. The one, if you ask me, is a setup function, which contains all one-time initializing codes. So we are making sure our pin direction for the LED, built-in LED, is output. And then in our loop, we are writing our LED value with high to start with, and then we are waiting for a second, and then write a low and wait for a second, and it's going to just toggle forever. That's why it's called as a loop function here. Let's proceed further compiling this sketch. So you have a verify icon here. So you may press this verify icon. So again, it's compiling here. Based on your system, it may take some time, and it's better to have this window a bit bigger so that we can see the compilation information on this. Well, it's done here. You can see it's done. Now let's connect our board. As soon as we connect our board, the power LED should come on, and then make sure you go to Tools and select a right port. Currently it's COM4 here, so my system has a COM4, and make sure you select your port, and then you may press this upload icon. So press the upload icon. This again will take some time, so you have to be just patient. Now when you get this connecting message, make sure you press the boot button on the board here. This is a boot button I have here. So press this boot button till you get a transmitting message there on the screen, and then you can see the board LED coming on and off toggle. Now that we have successfully transferred our first program and verified its output, let's move on to the next section. So before that, let's close this window. I would not like to save anything here, so I'll say no. Then let me switch my desktop, come back here. So we have seen all these steps, so let me just go quickly to the next section what I have. So we've done all these things. Now here comes the sensor part. So the sensor what you're going to use in this project is a simple LDR, a light dependent resistor. Its resistance just changes based on the light what falls on it, and the plan is to have just a simple voltage divider circuit here. If you ask me, I have a LDR connected here and a resistor here, and the midpoint is going to an ADC channel here, and the end of a resistor goes to the ground, other end goes to the VCC. It's a simple voltage divider circuit. So now let's interface an LDR. So this is a light dependent resistor, you can see here. So now I would like to switch off this board. I would like to remove this, and so there are some pins here. So there is a 3.3 volt pin here, it's a ground pin here, and this is our channel VP, that's our ADC channel. So I'd like to connect my sensor now to this board. So let me connect this to the VCC and ground, and then let me connect this to the ADC channel, and let me keep the setup ready for the future use. And let's proceed to the next part of our hands-on. First, let's try to see the PWM output on an LED, and then let's try to see the LDR reading. So these are the two major things which we'll be doing in the thing side. And let's switch to the hands-on side. Well, let's proceed to the next set of hands-on. So these sample codes have been provided to you in a folder called as units. So let me go through that folder. So this is what it is. It's a units folder you have here. So get inside that. The first one we have is a lamp. So if I open that, I would like to move the window here and expand this. Fine. So it's a simple program which generates a PWM output on the LED, the built-in LED what we have. So as usual, we start with the setup function. Here in setup function, I'm doing a setup PWM, LED PWM. So here I have a function called a setup PWM, where I do set up a LED channel with a frequency of 25 kilohertz and a resolution of 12-bit register, and I am setting my channel as channel 0, and I would like to attach that channel to an LED pin, that is built-in LED, which is on GPIO2. We have just now seen that. Once we have done that, in the main loop function, it's just a simple loop where I call a function called as glow LED with a value of I. So the value of I to start with is 0 because it's a static modified variable. So first I would like to send, or first we send a value of 0 to this, and we glow this channel with a value 0, and then when it starts looping, I'm just making sure I'm counting the I value to 4096. And once it becomes 4096, I set my value of I back to 0. So here you should have a output where you get a feel of the LED glowing brighter and then going off, brighter and then going off. So let's compile this code. It'll take some time. Yeah, it's done. And now let's again attach our board. So let me attach the board. So that's a previous LED coming on here, and I would like to upload the program. As mentioned, when the message of connecting comes, you please make sure press the boot button so that the code gets transferred. and you should see the LED output coming on the board like this. It's coming brighter and then going off, and then brighter and then going off. So that's it. It's a simple example of a PWM generation. And yes, just not to forget, the same functions we'll be using in our other examples. These two functions we'll be using in some other examples. Let's proceed to the next one. Let me close this. So let's move to the next one. So the next one is an LDR. So let's select that. Let's move this to the top and expand it. Yeah. So first what we do is we initialize the serial port at the baud rate of 115200. Then I do set up a timer. Well, so in setup timer, I am creating a timer variable, and I begin my timer with up count, and it is my instance. And this, if you ask me, is a frequency what we generally have. It's basically it's a math of 80 megahertz. You can observe here we have a message of 80 megahertz here, and then we attach the timer to this variable and we register an ISR, and the ISR will be triggered on an edge, and it's an automatic reload timer after every 1 millisecond, and I enable a timer. Now the basic idea is to trigger an ISR every 1 millisecond, and I capture my ADC value. So this is what a timer ISR here. So it's a timer ISR. So whenever 1 millisecond is over, and I capture my channel 0 value. So channel 0 currently what we have connected is at VP pin, so that's A0 here. And we just don't act on the readings what we get, we just take 100 samples first. Once I collect my 100 samples, I take an average and then update a global variable what I have here. It's a global variable I have here, and this global variable will be read by my main loop. If you observe here, I call my function called as detect light percentage. It's just a name. There I have two variables, one is current brightness level, other one is previous brightness level, and this is where I use my global variable ADC val. So I just update it with the current brightness level, and then I'm checking if the previous brightness is not equal to the current, and that is the current is not equal to the previous. I update it and I return the current brightness. So whatever value I am reading currently will be just printed on the serial port as a string. So this is where it is. So now let's compile this program. So I would like to compile this. Yeah, it's done. My board is already connected, so, and the previous output is running. Let me now dump this code. Yeah, let me press the boot button. So it's getting transmitted. Now what I have to make sure is, I have to make sure I open a serial port. So this is the serial monitor icon. So click on that, and you can see the reading started coming up on the screen. Okay, so if I take my LDR and show it to the brightness, you can see the reading is increasing on the screen. And if I make it darker, you can see the reading falls down. And if still I make it darker, just hide it, you can see it's going as much as to 20. The value is going to 20, and I open it, it just increases. So it's a simple example just to capture the light sensor value which is fed to the ADC port. Yeah, this is the pin, the channel 0. And again These are the same value, these are the same functions we are going to use in the future examples. So I would like to use this function as well as the timer initialization, and as well as these ISR functions I would like to use for our future examples. That's it. We'll proceed to the next one. Now that we have covered the thing, that is the device side, let's move on to the gateway. The gateway we use is nothing but a Raspberry Pi 3 board, which is based on Broadcom BCM283X SoC, and we all know that this is the most commonly used single board computer. Raspberry Pi has a support of Wi-Fi and Bluetooth built into it. The board has a Raspbian OS based on Linux. This makes it still easy for us to work on this board. Now we need to have a service running on the gateway which relays the data from the thing to the cloud, and this service needs to be following a protocol. To make it happen, we will be using a MQTT protocol. As we all know, MQTT is the most commonly used IoT protocol because of its simplicity and method of operations like subscribe and publish. So how does it happen? Well, as you can see here, there's a broker running on our gateway, and in our case the broker we use is a Mosquito broker, which is an open source most popular broker. So anything which wants to communicate with this broker either has to publish, so you can see here thing 1 publishes to the broker, same way here in this case thing 2 subscribes from the broker, or it's also possible a thing both publishes and subscribes. It all based on our requirements. So just because of this simplicity and simple implementation which helps us to connect, publish, subscribe and disconnect, and many other features mentioned here which you may go through later, makes us to pick MQTT as a choice. So let's jump to the next flow as we follow. Let's try to connect our thing to a gateway with the help of a broker and try to publish and subscribe. Fine, let's move on to the hands-on part. So in this simple example, we have to deal with two parts. One, the thing side, and the other one is the gateway side. Well, first let's concentrate on the thing side. So let me switch the screen and let me open the sketch. Let me navigate to the third example. It's here MQTT, and there's a sketch called as Node MCU. So let me click on that. So the window opens. Let me expand this. Well, fine. So as usual, let's start from the setup side. So first we need to set the serial port at the baud rate of 115200 because we need to see the connection activities. And then I would like to set the onboard switch what we have as input. So the onboard switch is a macro which is defined in node mcu.h. So you can see here onboard switch is at GPIO 0, and onboard LED we have it as GPIO 2. And I have some more macros like pressed release which we'll be using in later code part. So anyway, let's see that. Then I'm switching and I'm making sure the onboard LED as output. Then to start with, I am making my onboard LED as high. Well, and after that comes the Wi-Fi setup part. So here we need to make sure that we have to pass the SSID. So let me type my SSID here. It's Syed Adil, and the password is IoT test. And then comes the next one. Let's first see what is the setup Wi-Fi part. So it's a simple function where I pass my SSID and the password, and you can see it's all written in this Wi-Fi.cpp. You can see that the password and the SSID is passed here as an argument. Then I have a simple banner printing up, like attempting to connect the Wi-Fi SSID whatever I pass. And this is the main part. This is where I start my or initialize my Wi-Fi with my SSID and password. And this is just a simple loop which just waits till the Wi-Fi gets connected. And once it's connected, you just come out of the loop, printing the status of your connection. Now that's about a simple Wi-Fi code. Then let's go back to the Node MCU part here. Then comes the setup MQTT part. So in this function, basically we need to pass the broker IP. Well, we'll come to this part a bit later. First, let me finish this code once and the broker ID. So let's see what this function is up to. And this is defined in MQTT.cpp. So if you come up here, it's again just like our Wi-Fi thing. So first I get my broker IP in form of IP address integer part, and then I initialize a client with the broker IP, whatever I got, and whatever port number I pass, it comes up here. So I initialize my broker with the broker IP and the port number, and I just register a callback function. So whenever this subscription happens, so you may see this callback function will be invoked, which just prints a message arrived information from the broker, and which is stored in this payload. And what I do is I'm just going to accept a simple boolean value. That boolean value will be stored in this payload. It's an array, the first part. So I take it and I convert it into an integer and I store in a current state. So anyhow, we'll see this when we come to the main part. Then I enter my main loop. So in my main loop, I have two variables. One, if you ask me, is a publish topic, and other one is a subscribe topic. So you can have any topic. Currently I have a topic called as SL pole, which I mean like street light pole, and inside that I have a lamp and its state. So this is my published topic, and then in the subscription topic I have a similar one, lamp, state, and parameters, so where I can pass the control parameters if required. Then I connect my MQTT broker. So this function again, it is in MQTT.cpp, where you can see it again prints the banner and waits till the client gets connected. Once it gets connected, it prints its informations like connected to the broker IP address, and it's going to print whatever topic it's going to publishing to and subscribe to. And this is a place where you can see, you can observe this is the subscribe topic what I'm going to subscribe. Well, let's come back to the main. Then I just make sure I keep on looping. The client is just keep on looping. And now this is the main part. So as we have just seen in the above, we have initialized a switch as input. So whenever I press that button, I just toggle my current state, and based on that current state, I'm going to switch on or off my LED. It's just a simple LED on off code, and then I publish that information to the broker and vice versa. So same way, if you remember that we had a subscription topic here in this in a callback function. So this is where you can observe that current state of the LED can even be published from the MQTT broker. So now we'll see that while seeing a demo. So very well, that's it. This is from the thing side. So let me save this code because we had done some modifications of our IP addresses. But one more thing, we need to set the broker IP here. So for this, we need to go to the next part, the gateway side. So let's switch on to that. Well, this is my setup I have here. So this is my Raspberry Pi board, which is put in a box. So I have a wireless keyboard and mouse dongle here. So first thing I would like to do is to connect my HDMI cable. So I would like to have a monitor just to make sure I set my SSID and password and get my broker IP. So let me first power up this, and I would like to keep it in a corner so that it doesn't get disturbed. Now as soon as I power up, you can see the board starts booting up. So this may take a while to get a desktop screen. Yeah, we got it. Now this is a simple desktop we have on our Raspberry Pi. So as I told you, this is running on a Raspbian OS, which is based on Linux. It's a simple one. For first, let's connect our Wi-Fi. So mine is Said Adilia. So I would like to type the password again. IoT test. Oops, something went wrong here. Failed to set SSH password. Oh, I'm sorry. When I set up my Wi-Fi router, I made sure the password I gave is IoT testing. IoT testing. So let me see whether it's the same. Yeah, IoT testing. Now I have to make sure that this is also changed in my code. So let's remember that before we connect to the broker. Anyhow, first let's connect to the Wi-Fi of Pi. So let's connect it. So it may take some time. Yeah, we got it. So it's connected. Now the next thing would be like to log in to a command prompt or open a terminal. So just let's check our Wi-Fi IP address. fconfig. Yeah, I got my IP address. So this is going to be my broker IP now. This is what I need to set in my code in the device side. Well, what I would like to tell in this point is I would not like to work on this type of setup hereafter. What we'll do is we'll do an SSH on our laptop. So let me go to the laptop and let me open the terminal here. So what I would like to do is do SSH and 192.168.1.104. So this is the IP we have. Connection failed. Okay, fine. So first I would need to make sure that I need to start my SSH service here. So sudo service SSH start. Yeah, it started now. Let's again try. So I'd like to just press an up arrow and then press 1 minute. It's just an IP address. So it's pi at 192.168.104. So yeah, so it's asking for authentication. So you may type S and the password is pi. So yeah, we are up. Now I'm in my Raspberry Pi. So if I type ifconfig here, so I should see the same IP address what I have already got. So now let's go to the demo part. Well, let's come back to the code part. So before I forget, let me set the password correctly once again. As I told you, it was not IoT test, it's IoT testing. So let me change it. And just now we had seen the broker IP as 192.168.1.04. So let us change even that. 192, sorry, let me come back here. 192.168.1.104. So we are up in this side. So everything is set. So first let's compile it. So this may take some time. Let me just adjust the screens. Yeah. Yeah. So what we need to do is to press the button once the code is dumped. Let me just make this bit high. Yeah. Well, it's done. So now let's dump it. So let me press the upload button. So this may take a few moments. So now let me press the boot button. Yeah, it's transferring the code. And you can observe that it's trying to get connected and it's connected now. So I would like to show you this information on the serial port screen once. So let me click on the serial monitor and make sure the baud rate is set. It's set. I would like to press a reset one more time. So let me press a reset. You can see that it's trying to connect to Syed Adil, and then it's connected and it is publishing to this SL-port lamp 1 state as well as subscribing to lamp 1 state parameters. So let's move back to the gateway side now. Now I've already made sure that all the contents, whatever is required, is copied to the Raspberry Pi board. So first let me clear the screen, and then if I do an ls, so you can see there's a folder called as IoT conference. I have copied all the things here. So let me do cd IoT conference, and there our folder is cd 2 units, and we are currently working on the third example. So I would like to do 3 cd MQTT. So there are 2 Python files here. And the first one, if you ask me, is a publisher, and the second one is a subscriber. So first let's see the subscriber part. So I'd like to open that file, vi mqtt subscriber.py. Now first let me quickly change the background because I think the color is not properly visible. So let me go to colors, and the screen background I'll make it white, and the text is going to be black. So done. So it's better we close it once and open again. Yeah, I hope this is okay now. So this is a simple Python script where I make sure I import my MQTT PAHO library, and then there are 2 variables. The first one, if you ask me, is MQTT server. So this is nothing but my Raspberry Pi address. I have to make sure it's changed to 4. So let me change it. And this is the topic what we are going to subscribe. And this is the place where I'm going to create an object, and I call it as client. And when the client gets connected, I'm going to call this method on connect, where I print the connection status as well as I subscribe to the topic what I have here. And then similarly, whenever I receive a message from the thing, so this method is going to be invoked on message. So I'm just going to print the topic from where the message came and with the content whatever I got. And finally I'm going to just connect to the server. So this is where it's going to connect to the server at the port address 1883 with a least time out of 60 seconds, and just loop forever. So let's quickly run this code and see its behavior. Sorry, save it, and Python MQTT subscriber. Well, now my device is connected. So let me go to the thing side. So this is the button what we have configured as input. So I'd like to press that. So you can observe as soon as I press the button, the LED comes on and the message is published on the screen. So you can observe it. So I'll again press it. And that's it. So this is about the MQTT subscriber Python code. So let's quickly move to the next one. vi mqtt publish py. So it's a similar code. Again, I'm importing the PAHO library and I'm reading the user input, and whatever input I'm going to pass, it's going to be from the command line, and I'm going to connect to the server 192.168.1.104. It's already set here, and this is the subscription topic what I have made. And whatever user presses, I'm just printing on screen and publish to the topic with this input at this IP address. So let's run this. Python MQTT publisher. As I told you, we need to pass an command and argument here, and currently if you observe, the lamp is on, the LED state is on. I would like to switch it off by typing 0. So I press enter. So you can see that LED goes off, and I got a message on the screen here, And then I would like to continue with number 1. So the state is 1, 0, 1. That's it. Well, now that the communication between the thing and the gateway is already established, let's proceed to the next one, that is from the gateway to the cloud. If you remember, on the workshop day we were discussing about the platform AWS, that's by Amazon, which offers very good secure cloud services and offers a good computation power, database storage, and many other functions, which is helpful in business growth. And even we were discussing the reasons behind why it is so popular. If you see, this chart itself is an answer there, where already 68% of respondents are already running applications, and many people are in pipeline there, and has a good feature set, like almost all the use cases can be implemented, and the services are getting deeper and interesting day by day, and very good security compared to on-premises storage. And these were some reasons why we would like to choose AWS, like flexible, scalable, reliable, good pricing, lots of interesting free services, and the locations where and all it's supported, and many more. So more on this, I would say you may do a study, you may go to their website, you can find out what and all features they have. So some of the important services what they provide, you can see here is they help us to do computations, storages, and database, networking, and many. But today we would be interested in this part, that is the mobile and devices, because this is our services we are going to use. That's for IoT. So let's see our use case now, that the plan is to transmit the data from the gateway to the cloud. In fact, we will try to subscribe to the AWS, as well as we'll try to publish from the AWS. So this is coming under the part of hands-on session 4, that is Raspberry Pi 3 to AWS and back to RPi 3. So let's go to the other screen. Let's click on the web browser and let's search for AWS. So it's already there, so let me click on that. Fine. So this is their website, so you may just take your own time and read what and all they offer and how do they support, and how would you register for a free account. You can just click on this, create an AWS account. So if you click on that, it will take you to the page where you may create for 12 months of free trial. Well, already I have created it. Let me just go to the existing AWS account. So let me click on this. Yeah, so now already my email ID is there, so I just have to type the password here. Oh, sorry. Well, it's taking me in now. So these are the services they are offering. As I told you, it's huge. It's very interesting, and based on the situation or based on the requirement what you are working on, you may select. So currently we are interested in IoT. So if you scroll down here, somewhere you can see IoT here. Yeah, IoT core. So please click on that. Well, this is the page. So if you see, this is the default interface you have, and by default it is in monitor page, where you can monitor about your connection informations, like how many successful connections you have and how many messages got published and even subscribed, which protocol you have used, and lots of other stuffs like this. So since we have already done some testing, so this we are seeing some plots here, but if you are a new user, you may see these things empty. So the other side, if you ask me, in the dashboard, we can see some interesting things which we'll be interested in. One, obviously the monitor. Second, we would like to manage our things and we would like to make our thing secure, and finally we would even like to do our testing. So let's first go and create a new thing. So let me go to manage here. So if I click on manage, so there are already two things created. We would like to create a new one. So there's an icon here, so please create new, and there are two options. Currently I'm interested in creating a single thing. Let's do a testing on a single board, so that's why it's a single thing. So let me click on the create thing, and there are many fields which you don't have to really worry about to start with. Let's go and make it as simple as possible. So the minimum thing it expects is to give a name. So let's give a name for the thing. Let's call it as SL-poll, because this is the name we are trying to subscribe. And I would say you can keep every other field as default, not that important right now, and please press on next. This page is the most important one, because this is the page where it helps us to have our communication secure. So there are different ways to create certificates if you observe here, but currently the one which is put recommended, this is recommended here, so we'll go and create a certificate. Click here. So the certificates are created for our thing, and this is very important for us to save all these certificates. Without saving these certificates, we will not be able to communicate with our thing, and it is very important for us to have this, to have a secure communication. Well, let's download all these certificates to our download directory. So let's first click on the certificate. So I'd like to do save as. Yeah, I would like to create a folder, and then I would like to call it as certs, C-E-R-T-S, certs. Get inside this, save. Download the second one, save as. I'd like to give the same path, save it. Public key is not that important, but still it's better you download and keep it. But the private key is very important. Download it, save. And the last one, you have to download the root CA. So this will take you to the other page, and there are 4 possible encryption keys. You can take the first one. Based on your need, you may choose any one, but I would like to go with the first one, the Amazon root CA one. Click on that. Make sure you copy this certificate. Control C, I copy. Let me go to the download directory and create a new file. And let's call it as root underscore ca.pem. Fine. And then yeah, it's okay. You can just say yes, and then press Ctrl V. Save it. We close this. You may close all these pages. Done. And once this is done, don't forget to activate this certificate. So let's click on activate. Done. So let's go to services again, and in my history I have IoT core. So click on this, then manage. You should see your thing here. The next thing we should be doing is to attach a policy to our thing what we have created. Now a policy is nothing but an object in AWS which defines the permissions to the thing which it gets connected to. So to do that, please click on secure. Then there is policies. I already have 3 policies here. I would like to create a new one, so you may create on new, and point to be noted down, I already have something called as SL-poll policy. I would like to create a similar name, so SL-poll policy. I would like to name it as policy 1. And in the actions, I would like to have all the actions defined, so you may type IoT star. So I would like to do everything like publish, subscribe, connect, receive, everything. So that's why IoT star. and even the ARN, I would like to have all possible ARNs. So click on that, and then the next thing would be do allow. Done. So please do create. So a policy is created. So this is our new policy which is created here. Now as a last step, let's go to certificates. So there are so many certificates here. Now we need to find out which is ours. So for that, let's go to download and let's see what is the number, starting number. So you can see it's 88F8A. So these are our current certificates what we have downloaded. So go back to the web browser. So 88F8, this is the one. So you have to click on this and then attach a policy. So there are 4 policies, and if you see, this is the latest one what we have created. So click on that and then you may just press attach. And one more thing, click on that, attach a thing, and you can see SL pole here. So you may click on that, attach. Done. So we are almost ready. Now next thing we would like to do is a testing. Let's switch to the RPy3 console. Yeah. Then I would like to go one directory backward, /cd// for AWS. If I do ls, there's a directory called as certificates. Now we have to make sure that we copy all the certificates what we downloaded in this folder. So to do that, let's first log out from here, log out, and the certificates are in download directory. So let me do cd/mntc, and in this it is in users, Said Adil, downloads. So we see our folder here, certs. We need to copy this to that Raspberry Pi 3. So let's do one thing, let's do an SCP here. So SCP -r, since it's a folder, certs to pi at 192.168.1.104 : so let's type the password here, pi. All the certificates are copied. Now again, I would like to do a SSH there, SSH pi at 192.168.1.104. So let's go in. So you should see all the certificates here. Certs folder is copied here. Let me go back to the same directory, cd IoT examples, IoT conference, 2 units for AWS certificates, and I would like to move all the certificates here. So let me do mv /certs star dot. Fine. So I should see all the certificates here. Now these are some credentials we need to pass to the Python code. So let me go back one directory. If you do ls here, so there are 2 Python codes. One is AWS IoT pub, and other one is AWS IoT sub. So first let's try doing publish, and let's see what output we get. So let me open that code first, vi AWS IoT pub py. Now again, it's a simple code which is taken from AWS SDK what they have provided. So here we have to make sure first we import the AWS IoT Python SDK, and we first define a device ID called as SL pole, and the main topic is SL pole what we have created. So this is the place where we need to pass the certificates. So you remember we have just now copied all the certificates. So let us go to this line and copy our root certificate here. So I would like to do change all this, and I would like to type the root certificate here, and then the next one is a private key here. So the private key is this, and the next is a certificate path. So let's just do again, this is the certificate. Fine, so we are done. Then what we do is we create an object called as client by passing the device ID here. So the next is we need to configure the endpoint. So we have a REST API URL here. So in order to know this, we need to go back to the Amazon cloud. So go back to the cloud and click on manage. So you may click on SL pool. This is the device what we have created, and here you have a section called as interact. So this is the path what we need to type there, or we need to copy there. So since I'm doing an SSH there, I will not be able to copy it. So let me type it. I'll change all these things as A2 Q7 HM S880 Y LD7 hyphen ATS dot IoT dot AP hyphen south and let me just south hyphen 1 dot Amazon aws.com. So make sure you verify this path. If this path is wrong, you will not be able to communicate. So there's a mistake here. It's LD7 hyphen ATS IoT, and this is again it's a AP here, AP hyphen south hyphen 1 Amazon aws.com. So that's it. Let me pull back this, and then we have our credentials passed here, that root certificate path and the private certificate path, all the things, and then we are doing some connection configurations. So all these things are from the AWS SDK, where you may get the documentations mentioning about all these things. You may go and check it out. So what this program does is it just publishes to this LAMP state, okay, a new message with just a loop counter. The loop counter starts from 0, and then it just keeps on running in a loop, and after every 5-second interval it's just going to publish a message like message 1, message 2, message 3 of this kind. So let's save and quit, and let's run this Python code. Python AWS pub py. So if everything goes fine, they should start publishing. Before that it should get connected. So look, something is wrong. So let me do a control C vi AWS. It's already done there, so check it out. Yeah, this is Amazon. So let me just save and quit, and again let's run it. Control L Python. Well, it got connected and it started publishing here. So don't forget, the topic what we are publishing is SLPOL LAMP state 1. So we need to subscribe to this topic in the cloud side. So let me go to test, and then here let me type that topic sl-pol, it's capital pol /lamp /state. If things are fine, it should start getting messages. Well, nice. See, we got a message here, message 7 and message 8. So if you just see this, the 9th. So if I just do a scroll here, so it's all coming up here. The 10th message. Fine. So this is about publishing to Amazon. So let's go to the next part. Let me do a control C here. So let's go to the next one. So let me type vi aws sub.py. In this case, I have already made sure that the certificate path is already provided. Everything is given here, and even the REST API path is provided. This code, the only difference is there we used to publish. Here we are going to subscribe to the main topic SL poll, lamp, state, and parameters. So let's check how this output is going to look like. So let me quit this, clear the screen, and run the code. That is Python AWS subscribe. Fine. So it's connected here. So let me come to the cloud here, add the path /params, and then I would like to see already there's a message called as hello from Amazon. So let me publish this message, and if things are fine, it has to come up here. So you see, nice, it has already come up here. So that's it. So this is how we have made sure that we subscribe to the Amazon cloud as well as we published from the Amazon cloud. So let's move to the next part. So let me change the screen. So in example 4, we have seen how the data goes from Raspberry Pi to the AWS, and from there how it comes back to the RPi3. So as per our flow, the next one we have is to send the data from the thing to the broker and from broker to the AWS. So let's move to the next example, that is example number 5. So we have here, it is going to be the data coming from the thing to the Pi and from the Pi to the AWS. So let's again switch back the screen. And let me just clear all these things. Let me minimize these things. Yeah, so I'd like to close this for time being. Yeah, let's close even this. So let's open the next code. That is the 5th one, Sketchbook IoT Conference Units, things to AWS Node MCU. So let me close this also because we are done with all these things. Let me keep it in the corner and just expand its screen. So here almost all the things are same. So if you see here, we have the first example, lamp. I have just copied and pasted as is. The next one, the LDR. If you remember, we had seen there were some 3 functions: light detect percentage, setup timer, and ISR. And then the same MQTT what we have here. So there's a callback function here and a reconnect function and setup MQTT. It's almost all same. And then even the Wi-Fi function, which we have already done. So let's concentrate on the main code. So there's a small change in the main code. So let's see how does it look like. So as usual, let's start from the setup function. So I make sure I initialize my serial port at 115200 and I set up my Wi-Fi. Oh yeah, I remember this is the credentials we had given in that workshop. So let me change it to my SSID. So Sayyar Adil, and then the password is now changed to IoT testing, and the broker IP is now 192.168.1.104. Everything else remains the same, and there's no much change here. So I initialize my timer so that I can capture my analog value here. I initialize my LED PWM, and the subscription topics remains the same, and I have few variables here. The only difference in this code is instead of a button, I am going to take the data from the real sensor here and I fill it in a JSON package here, that is a JSON variable. So, and I remember that even we had an issue in this JSON library. We made sure we installed it. Okay, so I don't know whether I have installed it now. Let's try it. Anyhow, the main idea of this application is to send the lamp state, the brightness percentage, and the operation mode to the cloud. And I do publish the message. So let's try to compile this. So let me make it a bit bigger here. Well, nice. So I made sure this error is going to come. So it's prompting for Arduino JSON package. So if you remember, I told go to sketch and include library managers. So type, yeah, this may take some time, Arduino JSON, ARDUINO JSON. So I remember that we have to select this version as 5.13.4 and then install. Should not take much time if your internet speed is good. So I think I'm done. So let's compile it again. So it's saying the build option has changed, rebuilding all. Could take a couple of seconds here, so you have to be just patient here. So it's done. So let's upload the sketch. The board is already connected. So let me press upload button here. So this is again going to take some time. Yeah, so now you may press the boot button here. Yeah, it's transmitting now. Nice. I think it already started glowing. So let me press the serial monitor here again. I would like to do a reset here so that I want to see the activities. Oh yeah, nice. And it already started publishing some data to the cloud. You can see if I take my sensor and if I hide it, so you may see that it's 100% dark. I open it, it's 41% dark. So nice. Looks like the data is being published. So let's see how it is coming on the cloud side. Let's go to the Raspberry Pi here. So let me do a cd ... and let me go to the fifth example. Okay, so I have a server here. So cd server. Nice. And the certificates what we have already copied there in the example 4 can be copied here as is. So let me do a cp ... for AWS certificates *2 certificates. If I do an ls on that, it all should be there. Nice, it's all there. And now in example 4 we had two separate functions. Now it's all integrated into one single one. So let's see how it looks like here. So let me open that. vi MQTT py. So as I already mentioned, this is nothing but an integrated code of example 4. So there we had two separate codes to publish and subscribe. Here I have made sure it's done in only one, and I've already made sure that the certificate path is given here. So you can see it here, it's all given here, and even the REST API path is given. And if you observe there, so there were two sides. One is the AWS side. You can see here, it's from here to here, it's all AWS side. And the other one, the bottom side, if you ask me, is the thing side. So there are some small minor changes in this code. It's better organized. Like there we used to hard code the MQTT server, but here we are getting using the hostname NSI command. So pretty much everything else is same. And I hope you people will understand when you see this, look at this code. So let me just save it and close it. Let me clear the screen and let's try to run this code. Well, let's run this code now. Python and MQTT py. Yeah, fine. It looks like it's connected to AWS and it's connected to MQTT server here. So let me go to the cloud part and subscribe to a topic here, SL-poll. These topics have not yet changed. LAMP/state. Let me subscribe. And the board is already connected here. So if there's a change in the brightness, it has to come. Yeah, it's already started coming up, the data. So you can see that now the brightness percentage is at approximately 40%. As soon as I make it darker, you can see it has become 100% now. And you open it back again, so it goes back to 40. So looks like things are going well. So you can even observe the LED here. So when I make it darker, it grows on full brightness. As soon as you open it, it goes to a dim thing. Fine. So this is one part. Let's do one thing. Let's subscribe. Let's publish from the cloud. Let me copy this and send the data back to the device. But remember, now the publishing topic should be params, and let me make the mode as manual because it becomes very easy for us to control this, and it is very easy to understand that. So currently in the manual mode, whatever brightness percentage I give, it's going to glow as per that brightness. So currently make it 40. Let's remove this 47 and make it 0. And observe here on the board, the LED is already glowing here. So let me publish this. As soon as I publish, it should go off. So I publish. Well, it goes off. Then let me make it 100% again. So I make it 100%. And again I publish. So the LED should come on full brightness. So yeah, well, it's working. Now anything can happen here. For example, I make it as 10% and I publish. You should see that the LED goes dim. So this is how the data communication is happening between the thing and the cloud, as well as from the cloud to the thing. So this is all about the example number 5. Well, now in this example we have seen the data going from the thing to the broker, and from the broker to the cloud side. The next thing what we have to see is that the data going from the cloud to the app side. For this I have my colleague here who has good expertise in that. So I would like to do a transition from this point.
Thank you, Adil. Hello everyone, this is Mubin here. So I hope you remember me when we met last time in the EFI IoT conference. So as of now, we've seen how devices communicate with the local gateway using MQTT protocol, and how this gateway sends data to the AWS IoT core using MQTT protocol. From here, let's see what we can do with this data which is available inside the AWS IoT core. So what do we do with this data? So we have many devices sending huge amount of data, and using this data we can derive business intelligence out of it. With respect to our use case, we are going to use this data to monitor the device parameters. So let's see what we need to enable and set up inside the AWS core to access this data from a web-based application. Alright, so let's have a look at the complete AWS cloud architecture. To start off with, we have device information being transferred to the AWS IoT core using MQTT protocol. So as you are aware, this IoT device gateway, which is part of the AWS cloud platform, will receive the data from devices. So this data we can handle in many ways. So in our case, we're going to use this data and store it inside a database. So to do that, we invoke a rule using something called as AWS Rules Engine, which is part of the AWS IoT Core platform. So when we invoke this rule, the data which is available inside AWS Device Gateway gets stored inside DynamoDB database. So whatever information that devices are sending will get stored inside the DynamoDB database. This information, which is available inside the database, can further be used for monitoring and data analytics. In our use case, we are going to use this data available inside DynamoDB database for the sake of monitoring. So we should be able to do real-time monitoring of device parameters by using a web-based application. So let's have a look at the flow, how a web-based application will be able to retrieve the data stored inside the DynamoDB database. To start off with, we need to develop a web-based application which will run inside a standard web browser. So this web-based application needs to display the device parameters which is available inside the DynamoDB database. To enable this browser application to access the device data, we need to implement a web service. So in general, client application which runs inside a browser can access data from a web server using REST APIs. So we will use Amazon AWS REST API Gateway component to build a web service. So specifically, we need to implement a GET method on the REST API endpoint which we'll be providing to client applications. Now the logic for accessing the data from the DynamoDB database is implemented as part of a Lambda function. AWS Cloud Platform provides a component called as Lambda function, using which we can access data from DynamoDB database. So this function, in fact, can be implemented using JavaScript, Python, and Java programming languages. In our case, we are going to use a Node.js based application which is written using JavaScript to query the information available inside the DynamoDB database. This information, which is fetched from the database, will be returned to the client application, again using HTTP protocol. So I hope you got a complete view of how sensor to app IoT application works. To start off with, we had a set of devices which send data to an IoT gateway, and this data will inject into DynamoDB database. Further, a web browser will send a HTTP request to the REST API gateway, which will invoke a Lambda function to fetch the data from the DynamoDB database. This information will get displayed inside the web browser. So let's move ahead with the implementation. Now, to implement this entire stack, we have two options available. The first one is a manual method wherein we select individual components from the AWS cloud, configure it, connect it, and test them individually. So to do this, it requires a lot of manual effort. The second option is a better option wherein we can use AWS Cloud Formation Service. We will use AWS Cloud Formation to set up the entire software stack. To enable AWS Cloud Formation to create the stack, we need to create a template document. So in our case, we have already created a template document which internally creates the components of the software stack. This will be shared with you. So advantage of using this stack is we can avoid the manual configuration and creation. It can also be used for repeated creation of the stack. So let's see how we can create this software stack using a template document. Let me select the web browser. So you can see we are already logged into AWS Web Console. So from services, we need to select CloudFormation service. I'm going to type CloudFormation. You can see the CloudFormation service. Let's select this. All right. So currently you can see we have already created a software stack called as IoT GS. Let's not touch that. So we need to create a new stack. Okay, so creating a new stack, we can select this create stack button. I'm going to click on it. All right, so you can see a screen to select the CloudFormation template. In our case, we're going to upload a existing template by using the third option available here. So let me browse and select the CloudFormation template which I already created. So you can see there's a file by the name slpole CloudFormation template. The extension is .json here. I'm going to select this now. All right, so I've selected the template which we have saved, and you can click on next. Now it's prompting for a stack name. I'm going to create a stack by the name sl-pole -stack. All right, so name of the stack is sl-pole -stack. So here we can see a new screen wherein it's prompting for some options. Let's ignore these options for now. I'm going to click on the next button. So here you can see it's asking for a confirmation. Let's select this checkbox and click on create. All right. So we are back to the main screen wherein you can see that a new stack by the name slpole is under creation. It's going to take few minutes till the stack gets created. So if you want to monitor the progress, you can see in the bottom pane the status of individual component creation is displayed here. So we can click on the refresh button to see the progress. As the components are created, you can see the status of the components getting created. So we'll have to wait for some more time till the stack gets created. Further, you can refresh and check the status. So you can see that it's under creation, and in case if some of the component creation fails, you will see an error status. By clicking on the error status, you should be able to figure out what is the reason for the error with respect to the stack creation. So let's wait for some more time till the stack gets created. I'm going to pause for a minute here, and after that we'll resume once the stack gets created. All right, so we can see that a slpole stack has been successfully created. More information about the stack creation and the logs you can see at the bottom pane. For example, you can see here that a REST API gateway component has been created successfully. If you scroll down, you can see that a lambda function has been created successfully, and further down if you see, you can see that 2 DynamoDB tables has been created. The table names also are visible here. So let's move on and have a quick look at the components of the software stack by selecting this stack. All right, so here you can see on the right hand side we can select other actions, and we can view the designer by selecting this menu option called as View Edit Template. So CloudFormation displays the components of the software stack in a pictorial representation. We can see here the components has been created and it is connected. So for example, on the top left you can see SL Pole REST API component has been created, and we can also see two DynamoDB tables has been created, and these tables data will get fetched from a DynamoDB function called as SL Pole lambda function read from Dynamo. So using CloudFormation template, we are able to create the entire software stack. If you are interested, you can explore this design template, and using the design template you can edit as well as add new components to the software stack. So for now we're going to use this software stack and test our sensor to app IoT application. Now let's go back to AWS IoT Core service. I'm going to select from the services menu IoT Core. So when I'm selecting, it's asking whether you want to stay or leave. Let me click on leave. Alright, so you're back to this AWS IoT Core monitor console. So let me add a new rule from the action menu over here. So I'm going to select the action menu. So please note that the CloudFormation template does not automatically create a rule. So we need to create this rule manually as of now. So to create a new rule, we can select the create button. I'm going to select the create button now. So here we need to specify the name of the new rule which you want to create. I'll name it as SL Pole to Dynamo. Alright, so I'm just giving a name so that it's readable and understandable. So name of the rule is SL Pole to Dynamo. If you want, you can give a description. So I'm going to write the description of this rule. Inject device data into DynamoDB. Alright. Now if you scroll down, you can see it's prompting us to enter a query statement. So typically, to specify what data you want to store, we need to specify the topic and the properties which you want to insert or select. Now in our case, we have already typed in this information in a separate window. I'm just copying it. So this query statement takes the form of an SQL query. So I'm going to select this statement which says select star from topic. So topic here is SL-pole /plus/state. So what it means is we are going to select all messages for this given topic. So let me minimize this window. I'm going to paste this query statement now. So select star from topic. That means we're going to select all MQTT messages. Now this query statement needs to be connected to an action now. So let me select the add action button. So here you can see various choices available for selecting a rule for an action. So I'm going to select the first option here which says insert a message into DynamoDB table. So our messages should get stored inside a DynamoDB table. Alright, so I've selected this option. Let me scroll down. you can see there is configure action. I'm going to configure this action now. Now here you can see a drop down menu to select a table name. So there are two choices. One is to create a new resource or a new table, or another option is to select an existing table. So let me select this drop down. So here you can see the name of existing DynamoDB tables. So we're going to select the table name starting with SL pole stack. I'm going to select the first table. Alright, so all our messages should get stored inside this table by the name SL pole stack, SL pole dynamo device status. Now here you can see that it's displaying a partition key called as device ID, and we need to specify the value of this device ID. So for now, I'm just going to paste the value which I already typed in this window. Right, the value has been copied. I'm going to paste this value. It specifies $topic 2. All right. So if you scroll down further, you can see we need to select a role to grant permissions. I'm going to select a role over here. So there are many roles which are already created. So in our case, I'm going to select the role specific to our solution. So you can see here, there is a role called as SL pole stack AWS IoT 2 Dynamo role. So you need to select this role for granting permissions for this action. Alright, so let me add this action now. So this action, once we have added, we can see in the previous window, you can see the action being added. I'm going to add another action for the same query statement. So this time we're going to insert into a different table in DynamoDB. So I'm going to select insert a message into DynamoDB, scroll down and click configure action. So in this drop down option for table name, here you can see there are two tables being shown with the starting with the name SL pole stack. The first table contains the device status, or most importantly is going to store the last device information or device status, and there is another table by the name SL pole stack SL pole dynamo time series database. So generally time series database is used to store data in a data specific to a timestamp. So continuous data we'll be receiving from devices. This data will be stored inside a time series database. Now here also you can see that there are two key values. One is a device partition key, other is a sort key. The partition key is by the name device ID. The sort key is by the name payload timestamp. So let me open the notepad wherein I have typed the key values. So first I'm going to copy the key for the partition key. I'll paste it over here. Again, for the second option, which is the sort key, I'm going to copy the sort key. So sort key here is timestamp epoch. Right, let me paste it in the payload timestamp. Alright. So next we need to select a role for granting permissions. So I'm going to select the same role which we selected previously, which goes by the name SL pole stack AWS IoT 2 Dynamo role. Now I'll add the action. So here you can see that we created a new role and defined two actions wherein we are inserting the MQTT data into two separate DynamoDB tables. So let me create this rule now by selecting the create rule button. Not sure what has happened. Looks like the rule creation has failed. Let me scroll up and check. Oh, so I think the query statement is not working. Let me copy the query statement again and try. So here there is select star from topic. Everything looks fine. I'm going to copy this once again and paste it in the query string statement. Let me paste it. Let's hope it gets created. I'm going to click on the create rule button. Oh, the same error is repeating. Let me scroll up. Alright. I'm not sure what has happened. Maybe the single quote is creating some problem when you paste it. At times I've seen this problem when you paste from an editor. The single quote is not getting recognized properly. Let me try again. Okay, so I just removed the single quote and manually typed it. Let me create the rule now. Alright, so it works. So this is a new learning for us, that when you type something in Notepad and paste it, at least the query string is not working. So be careful next time onwards. So we can see here the rule got created by the name SL poll to Dynamo. So this rule is executed automatically whenever data is received by AWS IoT Gateway. So with this, we have configured all necessary components inside AWS. Now let's have a look at the REST API Gateway service, which we created as part of CloudFormation template. So I'm going to access the REST API Gateway service. Alright, so you can see here API Gateway. I'm going to select this service. So on the left hand side, you can see the list of API services which we have created. Now in our case, we created the service by the name SL poll stack SL poll REST API. I'm going to select this REST API now. You can also select from here. I'm going to select this service, REST API service. Now here you can see the methods that have been configured as part of REST API service. So in our case, we are implementing a single method called as get method, and using this get method we should be able to fetch the device data available inside DynamoDB database. Now this REST API endpoint is used by client applications to receive data from AWS cloud. I'm going to select this REST API get method. Alright, so here you can see there is a option to test the REST API endpoint. So before I test, you can see here that on the right hand side, when you invoke this REST API, we are in fact invoking a Lambda function. So let's test this REST API now. I'm going to select this REST API. I'm going to test this REST API now. Alright. Now here, it's a test button. Let me select this button now. Alright. So we can see that on executing this REST API, we are able to access the device data. So the device data is available in the form of JSON payload, right? So various information like brightness percentage, timestamp, then you can see the state of the lamp, location. In our case, we don't have a real-time location, it's simulated location, as well as the device ID. So here you can see the device ID is lamp2. If I further scroll down, you can see there is lamp1, and you can see here there is lamp3. So what we have done as of now is we have connected 3 devices, and all 3 devices are sending data simultaneously. So let's have a look at another REST API endpoint. So you can see we have get, and there is a get with a device ID parameter. So this specific REST API displays the last known information about all devices. In our case, devices are nothing but street light poles. Now, if you want to access information specific to a lamp or a device, I can select this get REST API and I can pass a parameter here. Right, so let me select this get request. On selection, you can see it's giving an option to test this REST API. If you look at the API endpoint, it says /device ID. That means you need to pass device ID as a parameter. I'm going to test this now. So you can see here there is an option to type in the device ID. I'm going to type in lamp1 for now. So the name we have given is lamp1, lamp2 and lamp3. Alright. So I want to fetch the information about lamp1 now. Let me click on test. So you can see here, as of now there is no data coming because the device is not connected. Let me connect the device and we'll have to wait for a minute. Alright, so device is connected and it should be sending data. So I need to invoke this REST API again. It's not automatically refreshing. I'll select test now. Alright, you can see here. So as soon as the device is connected, device transmits data, and this data we are able to access from the REST API endpoint. Similarly, you can change the device ID. For example, I can type in lamp2 now instead of lamp1. I can get the details about lamp2 by giving the device ID parameter. Let me test this now. Alright, so as soon as I test, you can see the data changing. Here you can specifically notice the device ID property. Device ID is now lamp2. So the good thing about AWS services is that for every component there is a mechanism to individually test it. So this makes your development much more easier. So next, let's see how we can use these REST API services from a web-based client application. Now let's try to understand how the web application interacts with the web server to display the device data. I'm going to switch to another window. Alright, so here we have a web-based application which is written using HTML, CSS, and JavaScript. We'll discuss more about it later. This web application will communicate with the web server using HTTP protocol. So web client sends a request to the HTTP server using AJAX. The web server will respond back to the client with the device data in JSON format. So the client is going to send a request to the server. Server will respond back with device data in JSON format. So once the client receives this data, it has to display this data in HTML format. Now specifically, we're going to convert this JSON data into a HTML table format. And this table eventually will get displayed inside the web browser. Now, this is the entire workflow between a client application and a web server. Now let's have a look at the code which we have implemented for this web-based application. I'm going to switch to another window wherein we have the code. So here we have the files for the web-based application. So you can see there is a file called as index.html and there is another file called as app.js, which is a JavaScript file, and we have two directories CSS, which contains style sheet, mostly for displaying the HTML in a better format, and we have some images which are part of the HTML file. Now I'm going to open this directory in Visual Studio Code. So I'm just doing a right click, opening the directory using VS Code. Alright, so we have Visual Studio Code running, and you can see index.html is currently displayed here. So other than index.html, we have app.js and CSS and images directories. So index.html, if you look at the index.html file, we have a head tag. Like any HTML file will have head tag and body tag. So in the head tag, we have defined a title tag which shows the title of the application, which is Street Light IoT Dashboard. Apart from that, we are including two other files. One is the CSS file, main.css file, and apart from that, we are also including app.js file. Now here, if you look at the body, we have a heading which says Street Light Monitor. This will be displayed in the HTML window, we'll see it later. And we also have a div tag, and in this div tag we're going to display the device data in table format. So as of now, we can consider this div tag to be a placeholder. All right, and we're going to just display a spinner here till we get the data. So not much inside the HTML, we just have a div tag which in fact will be replaced by an HTML table. Now let's move on from here to the app.js file, which contains the main logic. All right. And here, if you look at the code in the beginning, we have two variables. The first variable is called as devices endpoint URL. Now this URL should be picked up from the AWS REST API Gateway endpoint. All right. Now let's go back to the AWS Web Console. So here we already tested the REST API Gateway. Now I'm going to click on stages. See here in stages we have a stage called as prod. One is a dummy stage, you're not using it. In prod, if you click on this prod, you can see the get method, and the web service is accessible from this URL, and this URL is automatically generated by the REST API Gateway service. Now I'm going to select this URL, and using this URL you should be able to connect from the web-based application. I'm going to select this, copy link, and I need to paste this URL in my JavaScript file. So I'm going to paste it by doing Ctrl V. So the URL has been copied now. So this is very important. So you need to specify the endpoint of the REST API Gateway. Apart from this, you can see there is another variable called as device ID. So here we have defined the device ID as lamp1. Now every device will have a unique device ID. It may not be possible to find out what is the device ID of a device, and you may want to make it configurable. Now for now, I want to keep things simple. We're going to access only the data specific to lamp1 device. Let's have a look at the functions which are implemented as part of this file. So to give an overview of these functions, to begin with, you can see there is a function invocation called as setInterval. So this is a built-in function in JavaScript which is going to invoke get device data function every 2 seconds. So we want to display the device data, or you want to get the device data from the cloud every 2 seconds. Let's see what this device data function does. In this function, you can see we are creating a URL variable, which is nothing but the main URL plus device ID. So every device, you need to specify the unique URL, which will be a combination of the device endpoint URL, which will be the REST API endpoint URL plus device ID. So this URL is specific to our device. Now, after basically constructing the URL variable, we are going to send a request to the web service. To send a request, we are going to invoke a function called as submit request. So submit request function will send a request using HTTP protocol, and this request will be sent using AJAX, which is nothing but asynchronous JavaScript and XML. Now, I'm not going to go into the details of how AJAX works and how the basically response is received. To keep things simple, this function is going to send a request to the web service, and the web service will send us a response. And response we're going to store in a variable called as data. So this data variable contains the device data in AJAX format. So once we receive this data, you can see here we are going to invoke a callback function which takes data as an argument. Now, so the callback function is defined as handle device data. If you look at this callback function, first parameter is error, second parameter is data. So assuming that the request goes through successfully and the server responds back with device data, we're going to use this data and invoke a function called as create table from JSON data. So this function takes input as JSON data and returns a table. Once the table is being generated from the JSON data, we're going to update the HTML placeholder which we saw previously defined inside index.html. So this is done using DOM manipulation. So the code for converting the JSON data from, the code for generating the HTML data from JSON is defined here. So you can see the function name is create table from JSON data, and this code will take the JSON data as input, and eventually it's going to return a table. So overall, this code sends a request to the web service using AJAX, and once we get a response, we convert the JSON data into HTML table, and this table eventually get updated inside the HTML placeholder which is defined inside index.html over here. So this placeholder will get updated with the table data. Now let's have a look at the web page by loading the file index.html in a browser. So give me a second, let me go back to the file explorer, and here I'm going to open this file index.html. Alright, so we have opened the index.html file in a browser, and here you can see the heading tag which is displayed, street light monitor, and you can see that we're not able to display the device data here. So the application is trying to fetch data from the backend, but there is no data coming from the backend. So the reason could be that the device is not connected or the device is not sending any data. So let's have a look at the setup what we have here. So on the table we have 3 node MCU devices which are all connected to the Wi-Fi network, and for one of them is LAMP1. So we have LAMP1, LAMP2 and LAMP3 devices. Apart from that, we have Raspberry Pi which acts as a gateway which is connected, and if you look at the logs on the monitor, so Raspberry Pi is running a Python based program which is going to basically push the data from the devices to the cloud. So you can see the devices are continuously sending data. But if you look at the app, we don't have any data coming in the dashboard. The reason being, here in the setup we can see lamp 1, the sensor has been made sure that it's not transmitting any data. We have closed the sensor, so it's in pitch darkness. It's not basically sending any data. There is no variation from the sensor. So let's make sure that the sensor sends some data, and I'm going to remove this phone, and the device should start transmitting data now. Alright, so as soon as I take it back, you can see the device start sending some data. So we have here a table which contains the properties displayed. For example, we have the brightness percentage, we have a timestamp, we have the mode of operation which can be auto or manual, we have another timestamp which is in epoch format, and we have the state of the lamp, whether it's on or off. If it's 1, it means it's on. If it's 0, it means it's off. And we have a property called as location, which displays the latitude and longitude. In our case, this is dummy data. And finally, the device ID is shown. So since we are receiving only data from lamp 1, the device ID is constant. So you can see the device parameters which is sent from the Node MCU device is displayed in a web-based application. And as the device keeps sending data, the page gets refreshed automatically and more data will be displayed. Now this is a very simple web application. So if you are familiar with web-based application development, you can do much more complex. Basically, information can be displayed using graphs. You can also send data back to the device by sending a post method, etc. So for now, we have just developed a simple application which is going to get the device parameters and display it inside the browser. So I hope you got a complete picture of how the device sends data from the Node MCU to the Raspberry Pi gateway, and from gateway to the cloud, and from the cloud to the app.
Well, thanks Mubin for giving us a complete overview about the cloud integration part. Before I conclude this video session, I would like to again go through the use case one more time as a summary. So what we had seen in this complete use case is we have a node which is based on ESP32, which transmits the data to the access point based on RPi3, and from there it is going to be transmitted to the AWS cloud. And using a web page application, we are getting all this information and it's being displayed. I hope you people have got some idea about this use case, and the artifacts regarding all this implementations will be provided to you. You may download it if required. Once again, thanks to you all for attending this video session.